Okay, so these first notes, you are reviewing how to find distance. What is another word for distance? Length. So, anytime you're asked to find distance between 2 points or the length of a line, we're going to be using one of these methods. There are 2 methods to find distance or length. The first is Pythagorean theorem. So that's what we're going to do first, is Pythagorean theorem. So open up your Pythagorean theorem tab. Pythagorean theorem. What do you need? What do you need in order to do Pythagorean theorem? Right, the formula, the actual Pythagorean theorem formula is a squared plus b squared equals c squared. But what do you need to perform this? Ah, there it is. A right triangle. You need a right triangle. Why do you need a right triangle?
Because it's 90.
Okay, yeah, it's a 90-degree triangle, but why? Not always. Right. Someone discovered one time that always the legs, when added together, after you square them, will equal the hypotenuse squared. So we need to have 2 sides that follow the graph and one that is diagonal, creating a right triangle. Now we have the letters A, B, and C. What is the only letter that it matters where it goes? C. Where does it have to be? The hypotenuse. The side across from where? Yeah, the side across from the right angle. The side that is the longest side. And does it matter where A and B go? No. So, we're going to have an example here. You're going to write the example in this blank dotted rectangle. So, example, find the distance between points A, which A is located at 2, 3, and B, which is located at -2, -2. So, what is going to be the first thing I do here to find the distance between these 2 points? I graph them, right? I put them on my graph. So, that A has a point at 2, 3. That 2 is what value? Your x value. Yes, it's your x value. So, which is our x-axis? Good. And the y is the? Wonderful. So, we have a point at 2, 3. That means from the origin, where do I go? 2 spaces to the right and up 3. Beautiful. There's our A. And where's B? Where do I go from the origin? Wonderful. That's our B. And then I just draw a line connecting our 2 points because I need to find that length. I need to find the distance between those 2 points. What do I now need to do? Yes. How do I create a right triangle here? Right. You follow the lines of the graph now, right? So you start at one of the points. It does not matter which. I'm going to start with B. And you follow the lines of the graph until you line up with the second point, and then you stop. And then you connect that point to the line you just drew. And there's our right triangle. Which of these lines has to be my C? Right. The line we're trying to find the distance of, the line we're trying to find the length of, the hypotenuse. Can I just count the length of this line? No, you can never count diagonally on a graph. That's the whole reason why we have to use Pythagorean theorem here, because you cannot count diagonally. But we can find the lengths of what? The other two sides, the other two legs, A and B. What is the length of the A? 5. And and B is 4. What do I do with those two values? I put them into our equation for which variables?
A and B.
Oops. Gosh. For A and B. Do I replace C with anything? No, that's what we're trying to find the value of. So A was 5 and B was 4. What is 5 squared? And what is 4 squared? And C squared is? Yeah, it remains C squared. And what's 25 plus 16? Is this my answer?
No.
Why not? Oh, the C is not all by itself yet. It's still being squared. So what is the opposite operation of square? Square root. What is the square root of C squared? C. And then what's the square root of 41? 6.43. Wonderful. Yes. So someone discovered I could explain. Actually, maybe I'll show you that video.
Yes, please. Yes.
Okay, after this, I'll show you the quick video explaining where the Pythagorean theorem came from, okay? Now, we are going to solve for the exact same problem, but with distance formula now. So, in order to use the distance formula, you need to label your points with x1, y1, x2, y2. Oh. So what I'm going to do this problem is I'm going to rewrite the points right up here. So what were they? 2, 3, and -2, -2. That 2 on our first point, what does that value represent? x1. What about that 3? What is that? y1, right? Points always go x, y. That -2 in front of the second point is the x2, and the second -2 is our y2. Good. So now what do? Yeah, you just plug them into your distance formula. So D is equal to the square root of what do I fill in for x2? -2. And what do I fill in for x1? And what about y2? What do I put there? And y1. Beautiful. All I did was plug in the values. Substitute the values in. Okay, so technically what could you now do? You could technically put this entire thing in the calculator and press enter, However, we are trying very hard this year not to rely as much on our calculators because next year in Algebra 2, your tests are 50-50 calculator. So we're trying very hard not to use our calculator. We want to do more mental math. So what is negative 2 minus 2? And what is negative 4 squared? 16. And what is negative 2 minus 3? Negative 5. And what is negative 5 squared? So, are these numbers looking familiar? Oh, they are. So, what's the square root of 16 plus 25?
6.403.
Yes, sorry. I meant what's 16 plus 25? And then the square root of 41 is? Now, I know I just said we're trying not to use our calculator, and then there you had to use your calculator. Later on in the year, we're going to learn how to simplify radicals. Yes?
I guess you know what the negative thing is? It's like squared.
Yeah? No, because first you have to add them. I see what you're trying to say, that you can try to cancel out that square because it's being square rooted. No, you first need to add them together. Because look, if we had canceled out the square and canceled out the square, this would be negative 4, and this would be negative 5. Negative 4 plus negative 5 is negative 9. Well, what's the square root of negative 9? Square root of a negative number is imaginary, so it doesn't work. You can't square root a negative number. Yeah. All right, any more questions here? Okay. Now on to midpoint. This is another fairly simplistic concept. The only tricky part here is differentiating between the two types of problems you'll get with midpoint. One type is where it just openly asks you to find the midpoint. The other type of problem is where it gives you an endpoint and it gives you the midpoint and asks you to find the other endpoint. So there are two things that need to be taught here. The trickiest part is differentiating between them when you get to a problem. So, what is a midpoint?
Point in the middle of the line.
Point in the middle. What else in math, or when else in math, are you finding the middle of something? So say I asked you to find the middle between the numbers 10 and 5. What is that? Not the median. The mean. The average. You're finding the average between 10 and 5. How would you do it? Morning. How would you find the average?
Write the numbers down and
No.
That's median.
No. Average is where you, yes. The average is where you add the two numbers together. Numbers there are, two. Same exact concept here. We're trying to find the middle between these 2 points, so we're going to find the average between the 2 points. This is called, or I like to call it the average method. So, first, what you're going to do is find the coordinates of your points. So what are the coordinates of that top point there? 2, 3. And what are the coordinates of this bottom point? -2, -2, just like we had in the distance problem. So, to find the average between these 2 points, you add them together. So what is 2 plus -2? And what is 3 plus -1? I mean -2, sorry. 1. And then, because we're finding the average, not only do we add them, but we do what? Divide by 2, because there are 2 points. So, what is 0 divided by 2? 0. And what is 1 divided by 2?
1/2.
1/2. Boom! Found the midpoint.
Can we do it as in a decimal?
You can do a decimal there. So, on the graph, if I'm going to plot that, it's right here. Doesn't that look like the midpoint? That's how you can check yourself. Any questions on finding the midpoint? Yes?
Is that the y-intercept too? Like the 1/2?
It technically is in this example. Will it always? No. All right, you guys go ahead and do example 1 and 2 for finding the midpoint. So, what did you guys get for example 1? Yeah, you took the 2 points and you did what with them? Add them, so we have 7 and 10, and then you divided both by 2, so you got 3.5 and 5. I'll keep it as 7/2. Either one. And boom, that's our midpoint. What about example 2? What'd you guys get? Perfect. So we took the 2 points, we added them together, and we got 2, -2. We'll divide those by 2. Oh gosh.
That's -2, -2.
Yeah, you're right. Thank you. So we get -1, -1 as our midpoint. Any questions on finding midpoint?
No.
Beautiful. So now we're getting to finding the other endpoint. So this is using a different method. Remember, to find the midpoint, we find the average. When we're trying to find the other endpoint, you use what I call the lineup method. Unfortunately, I can't think of a better name for it. Maybe you can help me out. So here, the lineup method.
The lining up.
They will tell you what is the endpoint and what is the midpoint. So I'm telling you right now that this top one is our endpoint, and this one down here is the midpoint, and we have to find the other endpoint. So to complete the lineup method, you first write down the given endpoint. So what is the coordinates of our given endpoint? 1, 4. And what are the coordinates of our midpoint? All right. So now, what you do here is you ask yourself, what did we do to 1 to get -3?
We
Subtracted 4. So whatever you do to the top, you must also do to the bottom. What is -3 minus 4?
-7.
So we, boom, found the x value of our midpoint. Now we need to look at the y. What did I do to 4 to get -1?
-5.
Subtracted 5. So whatever I do up top, I must do to the bottom.
Which is -6.
And so -1 minus 5 is
You don't have to do this method.
done.
So it's basically like
No, I do to find the other endpoint.
Would you have to draw the midpoint on the whiteboard game, or would you just have to get the coordinates?
Just get the coordinates, yeah? Any questions on how to find the missing endpoint? So go ahead and complete example 1 and 2 for finding the missing endpoint. All right. What did you guys get for example 1?
9, -7.
Right, you put the endpoint of 3, 5 first, and then went 6, -1 as your midpoint. And we added 3 to get to 6, so we do the same thing here. We add 3 to 6 and get 9. What do we do to 5 to get -1? -6. So -1 minus 6 is? That's our missing endpoint right there. That's our answer. So, in the next problem, what did you guys get? Yes. What was the tricky part for this one? Good. It purposely gave you the midpoint first to try to trip you up. But you guys are smart. You know what comes first. The endpoint. So we needed to write 1, 4 first, and then -3, -9. So we subtracted 4, and again we have to subtract 4, and then we subtracted 13, and we have to subtract 13. And that's our answer. Any questions on midpoint or finding the other endpoint? Or distance, anything at all? Okay.